Okay, so here's the review question. Great. What we're doing right now is I want you to put today's title, 3.1b, Data Transmission Mediums. And put today's date. Today's December what date? December the 3rd. Okay? Each note you have should have your title and it should have the date. Okay? What is a network?
The connection between more than one node.
Yeah. What's a, if you only have two computers, what are the computers called in a network, Wendy? The smallest network you can have is two PCs. What kind of network is this?
Point to point.
Okay, yeah. What's the other word for point to point? Yeah. It's peer to peer. That's a peer-to-peer network, and it's the most basic network. The smallest network are if you have more than one computer, what kind of network is it called, Chet? This is the smallest one. What is the bigger than that? It's called a. What is this? What is LAN?
Local area network.
Very good. If you have more than one LAN connected together, it's called a.
Wildlife area network.
Wide area network. It's called a WAN. So this is networking. Today, we're going to talk about how we connect. What is the medium? What does medium mean there, Wendy? What does medium mean? Have you studied about physics?
Yeah.
What is medium? What is this thing that connects? What is this right here?
Cable.
Right. Medium is how the data is sent. Okay? And data can only be sent two ways. Uma, what is one way that we can send data between two computers? There's basically two types of mediums. We can connect two computers using what? Yes. We can either use cables, please copy this down, or the other type of medium is called what?
What type of
Any red that I wrote on the screen, you should copy. We can use cables. You can see this is called a xian. It's called a cable, right? And we can have fiber optic cable. We have coaxial, twisted pair. Or sometimes we do not need xian. What do we call that type of transmission? Do I need to have cables to connect to the internet? Do I need to always have cable? What else can I use?
Wi-Fi.
Yeah, and Wi-Fi uses what?
Router.
What medium? How does Wi-Fi goes through what? What are these?
Waves.
Yes. I can use waves. There are only two mediums. In fact, if you use electromagnetic waves, you do not need a medium. Okay? Like Wi-Fi can go through space. It doesn't need a medium at all, but we still call it a medium because it's being transmitted through waves. But technically, in physics, it doesn't need a medium. Okay? So let's talk more deeply about the different type of cables. We have several different cables, and we have several different waves of communication. So let's find out a little bit more clearly about what this is all about. when we're setting data on a cable, this is a key term because sometimes your cable is very thin. Sometimes your cable is very thick. Which cable can send more data? A thin cable or a thick cable? It's thick. In a thick cable, you could also maybe have more than one line in there, right? Thin cable, maybe not so much. And so this is called bandwidth. Okay, I want you to copy down this there, Chad. Bandwidth is the rate or the bits per second the data can be transmitted. For example, if I have a bandwidth of 2 bits per second, this is not very fast. But this means that in 1 second I can send a 1 or a 0, right? Just 2 bits. And usually the size of your cable or the method that you send, some lines use light, fiber optics, and they can send data much faster at a higher bandwidth. Okay? Do not copy this part right here. We just need to talk about bandwidth. Uma, in your own words, explain what is bandwidth.
How much data can be transferred to the network?
Okay. Wendy, what is the units?
At a rate.
Yeah. What is the rate of transmission called?
Bit rate.
Bit rate. And it's measured in seconds. Okay? So we call bits per second.
BPS.
Yeah. Okay. Now, we're going to take a note about different type of cables. We know that there are 2 methods of transmission. One is called cable. Now, we actually have different types of cable. Okay? This is the very first one. It's called copper. We can have copper cable. Copper is the most common and cheap method of networking. We don't necessarily use Wi-Fi all the time. Okay? Most of the internet is from cables. Okay? 线. And what is this right here? Inside has copper. Okay? So the very first type of copper, we actually have 2 types. One is called Ethernet. Ethernet cable. An Ethernet cable is basically you have some twisted pair wires. Okay? You have some wires that are twisted and they're wrapped together. Okay? This is called Ethernet cable. And you have 4 pairs of twisted wires, and we use that connecting to the internet. Okay, so let's just write this down. Ethernet cable, we call this Cat45. Okay, it's called Cat cable. The newer one is called Cat5, and it's composed of 4 twisted pair wires. Wendy, why do you think that we take the liangxian and then we twist them together? We wrap them together. Why do you think we twist it?
More harder.
To make it more harder? Uma, what do you think? Why do you think that we twist the Cat5 cables? See those cables, we wrap them around in a circle around each other. Why do you think we do that?
Doesn't it help with the way the data is tracked?
Okay, how does it help? You're correct. Okay, Chen, why do you think we twist the cable? Why do you think we wrap the cables like this? We call it twisted pair for a reason. Why? Do you have some idea? No? Okay, here's the answer. Pay attention. Now, we could just have a wire going side by side, but we do not do that is because,
Is it because it like cancels the interference?
yeah,
So it
when, yes, we have these things called electrons. Boop, 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 boop. And if you know about physics, when you have electrons move, they create this thing called what? What is this little blue thing that I'm writing? This is called a magnetic field. And what happens is this field can induce electrons or currents in other wire. This is called crosstalk. Crosstalk. Crosstalk is when the wires are too close together, and so one, as signals go through the cable, he can affect the electrons in the other wire. Okay? So the reason why we twist is these electric fields will cancel each other out. One will be going this way, one will going that way. And then it will equal to 0. We twist the wires, and so we don't have crosstalk. What is crosstalk, Wendy? In your own words. What is crosstalk? Cross means what?
Go across with
Yeah, it means that as this line is communicating, we're actually going to send some data into the next wire, which is bad, because we can change some bits. Okay? So let's write this in our own words. Crosstalk is what? Is when what? Help me finish it. Is when, yeah? Can we kind of explain this idea?
It's when like the two wires that
Yep. Two wires.
cross with each other and there is a connection.
Will it happen if the wires are far apart? Will crosstalk happen if the wires are far apart? No, because the magnetic field has a specific distance. So it's when two wires are far or close together.
Close together.
Yeah. Is when two wires are close together. Can you copy this there, Chen? And how do they talk? How does this data all of a sudden jump there, Uma, between one wire and another? We have to use a key word. How does the data jump? The wires are not connected physically, but somehow they go through the air. How do they go through the air? Yeah? Yeah. Because of the magnetic field that is created around the wire. This goes through the air. So crosstalk is when two wires are close together and electrons go into the second wire. Due to magnetic field interference or induction. Okay? Induction just means it's inducing. And we can fix this by twisting the wire. Is that clear? And this is the most common. Ethernet cable is the most common networking cable within a LAN. Within a LAN, in a school, all those little ports, they all use CN. And this is actually one of the most reliable networking thing. It's not Wi-Fi. It's actually using cables. Okay? Using cables, you're not going to have to put in the user's password. You just plug in the cable, and it's harder to hack. Wi-Fi is very easy to hack because it broadcasts everywhere, but the cable, when you plug it in, it's safe. It's safer, and it's faster, can be faster than Wi-Fi. Okay? But some downside is you have to pay money because it has copper inside. Now, the second type we have is called coaxial cables. Okay? So, in your note there, Ethernet cable, can I check it off? You guys are okay with the Ethernet cable? It's basically 4 twisted pair, so 8 wires twisted together so that we don't have crosstalk.
Mr. Newson,
Yes.
would it extend, I mean like, how to explain like easily that why they twist each other?
Because to stop crosstalk. The answer is to stop crosstalk. Yeah. We twist so that we don't have crosstalk or interference between the cables. Yeah. Okay. In copper, we have a second type of cable. Okay? That uses copper. The second one is called, anyone know the name? Used by the TV companies. Anyone know this? This guy right here? He has a single copper core. He's called coaxial cable. Right? The second type of transmission is called coaxial cable. Coax, and he's a little bit older technology, but he still uses the medium of copper. Okay? Coaxial cable is mostly used by the TV company. It's used for TV. Okay, so you just have to remember, it's like TV. It has a single core. What he looks like is, I'm going to erase this right here so I can write a little bit more about the coaxial. Coaxial is just a single wire. It's a thick, single wire with a sheath. Okay, so he has the wire here, and the sheath right here is to protect him from the interference. Okay, whereas the Ethernet, it has twisted wires. The wires are twisted together. I'll just show you a quick picture. You don't have to know too much about that. It's just that it's usually used by the TV companies, right? It can't easily be bent. It's also used by internet companies. We have a plastic thing is because signals, these are an insulator, okay? Because each cable should have a sheath. Can you have a look here? They have a plastic sheath so that the wires don't, don't get wet. Okay. They also can protect it from magnetic fields and things like that. Okay. It has a thick insulator. Okay. Now, this one is called fiber optic because when I want to send really far across the sea, what kind of cables do I use? What is this called? Ched, how to call this cable? Fiber optic. Fiber optic is right now the fastest method because it uses what? Does it use copper there, Uma? Fiber optic cables. What do they use to transmit the data? What is it made from? What are these made? These fibers are made from what?
Plastic.
Yeah, you're right. They're made from plastic. Is plastic expensive? No. And what is the fastest thing in the world? It's light. What is the speed of light? Who's studying physics? C. Big C. What is big C equal to? Can someone tell me? Who's studying physics? Are you studying physics? What is the speed of light? Fastest thing in the universe. How many meters per second?
800
3 times 10 to what exponent? 3 times 10 to the exponent 8 meters per second approximately is the speed of light. It's the fastest thing. And so when we're talking about cables, we can have copper, right? Copper, we have 2 types. We have twisted pair, or we have Ethernet. Ethernet cables. We have coaxial. And then the other type of cable we have is use the light or plastic. The plastic one, basically what happens is we have plastic and we shoot light through, boop, 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 and it has an index of refraction, and then the light propagates through the cable. There's a problem with this. What is the problem with fiber optic? What's going to happen if I have a corner? If I bend my plastic too much and I pinch, my wave can get stuck. Did you know? You have to have a specific angle, and if the angle doesn't work, to bend too much, you cannot bend a wire like this. Copper cables, it's very fan bien. You can bend it any way, and the electrons will follow me. But light is not like that. It has to bounce. And so inside the plastic, they actually have to shoot the light on an angle. And you have to have total internal refraction. Okay? So just note, let's just write the note here. Fiber optic is the fastest, has the highest bandwidth, but what is the biggest downfall, Wendy, of fiber optic?
Can't be bent using refraction of light.
Yeah, can't bend the wires. Can't bend the wires. To make a long bend, you can do it very slowly, but it cannot do 90度. Cannot do 90度because it uses the bouncing of light refraction. Okay? So cables. Tell me 3 types of cables we can use. Chet, 3个线. Tell me 3 types of cables.
Wire.
那个线. We have 3个线. One type is coaxial cables. Uma, tell me other name of a cable. Say it one more time. Fiber optic. Tell me one more type of cable.
Ethernet cable.
Ethernet cable. Okay? Those are the 3 types. And you don't need to copy all this down, but they have these big rolls. And underneath the oceans, what type of cables do you think they use? Ethernet, coaxial, or fiber optics there, Uma? What type of cables do you think they use? When we go across the ocean, this is the world map of all the internet cables. What type of cables are these that go really far distance? Ethernet, coaxial, fiber optic. What one do you think is used? It's not Ethernet. It's not coaxial. Why? Most of the cable under the sea are fiber optic. Because it's fast, and what's the other reason? What is it made from? It's made from, and it's cheap. It's fast and cheap because it's made from plastic. If I had to do all these cables use the 铁子, the copper. Do you know Cu? Cu? Copper? In 化学. You know, in 化学, we have Cu, stands for copper. Do you know this? It's a piece of, it's metal. Do you know copper? How to say copper, Wendy, in Chinese?
Home.
Okay? And so most all the cables are using fiber optics between Europe, America, China, all use the fiber optics because light is the fastest. When it hits the land, Uma, is it still using fiber optics? Do you have fiber optics that go to your home in the UK? Yeah, you can still have fiber optics to go to your home. And then in your home, do you have fiber optics in your home?
Yeah. Maybe.
You have fibers that go to your home, but in your home, we don't use fiber optic because it's very hard to bend. So what do we use in your home? What are these?
Twist.
Yeah?
Yeah.
What is it called? What's his name?
Twisted.
Twisted pair, but
Yeah.
he's called Ethernet cable,
Oh yeah.
Cat5,
Oh yeah.
and we call them twisted pair. The wires are called twisted pair inside. Okay, this is just a little overview about how the internet's working. Look right here. The cost. Sorry. The materials is not expensive, but since it's the best, lots of people want that technology, and it's supply and demand. Therefore, usually fiber optics they charge more money, but it's not expensive to make. Bandwidth, fiber optic is the fastest. Interference, twisted pair is the worst, so you have to twist it. Coaxial has less interference. And so, who's the winner for the cable? Who's the winner for the cable here, Wendy? What is the best way to transmit the data, according to the communication table here?
Using fiber optic.
Fiber optic. Fiber optic's the winner, but the downside is, what's the problem, Ched? What's the problem with using the Youngwang? What's the problem? What can fiber optic not do?
So,
Can I do this with the Xian?
no.
No, it can't bend very well. You cannot go 周速度. This, look, I can bend it because I'm bending the copper. And my internet is still working on my TV. But if this was using light, and I go like this, what's going to happen? Uma, what's going to happen if I bend like this, a fiber optic?
The data will be open stuff.
The internet will not work is because the light can't bounce around the corner. Wait. Last thing. We know we have two computers. You can connect with cable. What is the other way that you can connect their Uma? We can connect through cable. What's the second type? It's wireless. We can connect through the air, right? So there's only two types of, in cables we have a whole bunch of different types. We have Ethernet, coaxial, fiber optics. Agree? Now, the other one is we can connect using waves. Okay? In here we also have three. One is called UV light. Okay? What happens is we have a sensor and we go boop, 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 boop. We shoot infrared light. Sorry, I think it's infrared light. Okay? It's not UV light. That's what the sun gives us. It's a red light. I can even change the color to red. They shoot this red light, and this is called infrared. Okay? Infrared. Okay? This is a wave, it's a light, and they have a sensor between the two computers. This can only work if there's nothing in between. The infrared light is a very high frequency. He cannot go through wall. 对还是不对? Infrared light, sometimes they have speakers, and they bounce the light, and you can communicate. Okay? So write down wireless. 你需要写 wireless. We have 三种, 3 types. Infrared. The other one is called radio. We use the radio. Radio is the same as Wi-Fi. What is Wi-Fi? Wi-Fi uses the gigahertz. 举个例子, 2.4 gigahertz. When you say I connect to the Wi-Fi, it's using radio frequencies. Okay? And can Wi-Fi go through walls? Uma? Right now I have Wi-Fi. Yeah, Wi-Fi can go through walls. Okay, it's not as high as infrared. The higher the frequency, he cannot go through wall. Okay, Wendy, can this light go through this wall? So see this white light. It's hitting this wall. Can sunlight go through walls?
No.
No. Okay? So when we're talking about waves, we have, and then we go very high frequency and then bzzz. What type of frequency is this? There, Chet. Is this high or low frequency? This right here. Is this
high?
Frequency is measured in number of waves per second.
Also, this is low.
This is low frequency. For example, the radio wave. And then over here, we have very high frequency. This is like natural light. And we also have infrared. IR light. Infrared. Low frequencies, just pay attention right here for a second. Low frequencies, if you have a cell phone tower, they can bounce. And they can go through walls and mountains and things like that. The high frequencies, like light and IR, cannot bounce. It's just like natural sunlight. Natural sunlight, when it hits the wall, it stops. Because sun is very high frequency. But radio waves are lower frequency in the gigahertz. They can go through the walls. So just remember, high frequency, it has higher speed, but it can't bounce. Okay? So this is kind of the key things here. Okay? What is this? There, Ted. What type of internet?
Network card.
Yeah. Is it use cable or waves? 线还是
waves.
It uses the waves. Okay? I already talked about that. What is this right here? Uma. In the space, can you communicate in the space? Do we have internet in space? Yeah? What is the internet from space called? So we have actually 3 types of waves. We have IR. Okay? This is using light. Wendy, can you just don't look at the laptop for a second? We have, tell me what is IR? It's the red light called infrared. And then we have Wi-Fi, right? Wi-Fi is the radio. The last type we have are microwaves. Microwaves. And what are microwaves are in the satellite. We have these satellite here. And so from your laptop, you're using like the Wi-Fi to a Wi-Fi tower, and we can also communicate through 3 different types. When you go to the internet, you're going to use cables. You're going to use maybe some sort of Wi-Fi. You'll use all these different mediums. Your packets are going to go everywhere. It'll go the fastest way. The one that's not used the most is IR. Okay? Very seldomly you'll use infrared, but mostly you're going to use Wi-Fi, which is radio waves, and microwaves. Microwaves are satellites. And I'm just going to have a quick talk about that. Cell phone towers, they have, since that they're high frequency, Wendy, I need you to pay attention. In China, this way, they use this thing called cell grid. And since it's high frequency, they have to be able to see each other. If they don't see each other, you can't really transmit. Okay? And so the key thing about these internet towers that using waves is they're using line of sight. And that's why in China you see many cell phone towers. It uses the radio frequency. Multiple users can connect to any of these towers at the same time. Okay? You can actually track people with just using 3 cell phone towers. You can actually figure out where a person is based on the time to transmit and receive. Okay, like the hackers. Okay? So that's it about the waves. Okay? We have 3 types. One is Wi-Fi, which is radio waves. One is infrared. Infrared is using the red light. It's not used too much. And then the last one is the satellite. The satellite is microwaves. Okay? So just have these 2. IR, Wi-Fi. Microwaves is satellite. How to say satellite in Chinese? 卫星. Cool? Do you have this copy down there, Ched?
Okay.
These are the last mediums that are using waves. Okay? Okay. Your schoolwork. In your own notebook, I want you to answer this question. This is from a previous test. So this is your schoolwork. Cell phone network. Wendy, can you read the question? And then I'll get you guys to...
Smartphones use a cell phone network to connect to the web. Explain how data is transmitted using the cell phone network.
Okay, so you need to maybe draw a picture, have a look back at your data, where you have the different towers for the cell phone network, and then explain. So this is just the conclusion of today. I just put this one problem for you guys to have a try, okay? So take 5 minutes, have a look at your notes, and then maybe draw a diagram, explain how to transmit using a cell phone network, okay? And this is 4 marks, so I'll give you some time to work on this. If you have some questions, you can ask me, okay? I'm going to pause. Okay. I'm gonna take this up. Okay, when we're talking about the Wi-Fi for the cell phone network, how is data transmitted? Can you tell me some things? We need each person give me one thing. Uma, how does data be transmitted wirelessly? Yeah, tell me one thing.
The phone converts data into radio signals.
Okay, yeah. The phone converts data into radio signals. To send to the tower. Okay, very good. Tell me something else, Ched, about the Wi-Fi cell phone network. Tell me something else we talked about Wi-Fi. How do you communicate wirelessly? You can have a look at the PPT. Wendy, tell me some other key property about transmission of wireless communication.
They transmitted by waves in the air.
Yes. Okay, we got radio signals. Okay. Tell me something. Yes, we got that. Radio signals. Tell me something else. How about the distance? How far can radio signals go? How far do the towers have to be?
Towers have to be that at least can see each other.
Yes, because we're using the higher frequencies, they can bounce a little bit, but have to be line of sight. The cell phone towers, the cell phone towers. Let me just change the color here. The cell phone towers need to be in line of sight. Okay, we have two. Okay, Ched, tell me one more thing. Cell phone have to be radio signal. Cell have line of sight. What is some other key property of cell phone Wi-Fi towers? Wireless.
Wireless network interface card.
Okay, you have to have a NIC card. The phone converts data into radio signals. Yeah, we could say that. Cell phone NIC card IP address is used to transmit and receive data from closest tower. You're going to talk to the closest tower. That's a key property. Okay, we need one more. Uma. Key properties about wireless communication. Radio signals, line of sight. We have a NIC card. Use it. Okay, yeah. Towers can return the data to multiple devices at the same time. Basically, they can transmit, receive, they have antennas, something like that. So you save the 4 things about the transmission, and we should be good to go. Okay, it could be, this is an example of waves, but there could be other one about cables. Okay, but it's the same idea. This is from a past paper. All right, great. So your schoolwork, okay, is 3.1 questions 5, 6, 7, okay? Chen? These are the questions about today's note. If you finish, please have a try with the programming about the arrays, about the level 4. That's a good problem, a fun one to do too. And then I will upload this. Okay. All these notes do appear on the OneNote, okay? So you should have a look. Oh, we need to stop. Okay, stop. Why is this not stop?
Sir, this is my